Hello again, this is Mike Wickstrom with Reed Concrete Pumps. Now that we know and understand how to reset our emergency stop in order to enable the machine, the next thing we're going to cover is the function of the machine. How exactly does a concrete pump function? First of all, we're going to cover some of the components, learn what they do and how they operate together to make a machine actually pump concrete. First of all, we all know what an engine is. We're not going to spend any time here. All of our machines are equipped with a main hydraulic pump and an auxiliary hydraulic pump. So these units are going to have a minimum of 2 functioning hydraulic circuits. If you have an agitator or hydraulic outriggers on the back side of the machine, that's going to call for a 3rd auxiliary circuit. So first of all, we know what the main pump looks like. The only thing that this main pump is responsible for is for flowing oil to our 2 main hydraulic cylinders that are hiding underneath the engine. Now the hydraulic cylinders are connected to a pair of concrete pistons. So as these cylinders reciprocate back and forth of each other, they're going to be drawing concrete into the concrete cylinders on this side, and then obviously pushing the concrete out. So, main pump, flow control valve to limit the amount of flow flowing to these cylinders. This valve allows the machine to cycle the speed of the cylinders independently of the engine RPM. Okay, so we've got the main circuit covered. Next, we've got our auxiliary pump, which is a gear pump. It's going to feed oil to our swing tube circuit. Okay, and the swing tube circuit consists of the pump and a cylinder. Now the cylinder is connected to the swing tube, which is hiding back here in the hopper. It is basically transferring back and forth to the loaded cylinder, the cylinder that has just been filled with concrete. Okay, now there's other key components that make this machine cycle. Okay, and this is where we're going to take a good look at the manifold and discover what it does. The manifold on the A Series units are mounted right to the main hydraulic drive cylinders. So it eliminates a couple of hoses, fittings, and connections for a possible leak. This manifold is hiding right up under the engine, underneath the radiator section. Okay, now this manifold serves a couple of functions, but essentially it's controlling our 2 circuits, the main circuit and the swing circuit. Okay, we've got a manifold here just for better view on our cart. Okay, this manifold, this is where your accumulator would be. We don't have one mounted on this manifold right here, but on your machine, the accumulator is going to be right here. So this would be the non-operator side of your machine. This side here would be the operator side, obviously. Okay, so let's focus on these components, and we're going to find out what exactly is going on here. When we start the machine, as we just learned in the prior video, the machine is disabled until we reset the emergency stop. Okay, what happens when we reset the e-stop? Once the e-stop's cleared, it powers these 2 dump valves. Okay, these 2 dump valves are in with the swing circuit. Now, as soon as these coils get energized, it causes the cartridges to close. Now the machine will build swing tube pressure. Swing tube pressure is key on this design because swing tube pressure is where our pilot oil comes from. It actually shifts our directional cartridges. Okay, so we have our dump valves here. This is known as a double pilot valve. This valve here is what's making the cartridges cycle back and forth. So imagine we've blown the horn. We've got swing circuit pressure shown on our gauge. This valve is going to have swing tube pressure introduced, waiting, right at the P port, the pressure port. Now as soon as we turn the pump switch on, the computer is going to resume its last cycle and energize either A coil or B coil, whichever one was energized before we shut the machine off. So as soon as we energize the cartridge, the spool inside shifts, and that's going to distribute a pilot oil signal two different directions simultaneously. Okay? It's going to come to our swing circuit directional cartridge, which is going to shift the swing tube cylinder. On the other side of the manifold, we're going to shift the main directional cartridge, which is located right here. So, once the unit is cycling automatically, every time one of these cylinders reaches the end of its stroke, a coupler is going to signal a proximity sensor that's in our flush box. The proximity sensor provides an input signal to the computer. Okay? When the computer sees that signal, it responds with an output signal. Really all the computer's doing is it's juggling a power signal back and forth all day long. So every time we energize one coil or the other, remember, that pilot signal gets distributed to both ends of the manifold. I mean, if you were to saw this in half, you could think of this as the swing circuit side of the manifold. This would be the main circuit side. So now that everything's cycling and hunky-dory, the last thing we need to talk about here is our reverse valve. That's the only responsibility of this valve here. It's a single coil, doesn't have two like our main valve does. And when we kick the machine into reverse, which is usually necessary when you encounter a line plug, you need to relieve that pressure. So by flicking the machine into reverse, we energize this reverse valve, thus reversing the pilot signals and ultimately reversing the main drive cylinders to get the machine into a suction type of pumping. Okay. Hello, Mike Wickstrom with Reed Concrete Pumps again. Now that we have a basic understanding of what and how our machine cycles, we're going to go a little bit deeper into this system and learn how pressure is managed. Starting with the swing circuit, because again, with the A Series machines, these theoretically can't cycle unless we have swing pressure, because once again, that swing pressure is used as pilot oil to shift our cartridges. Okay, now how does swing pressure happen? Well, first of all, it starts with the gear pump providing our oil flow. Okay, once again, the first path of flow is going to be across these two dump valves. So if these valves are open, aka de-energized, nothing's going to happen because the oil flows right back to the tank. Once we blow the horn and energize these two coils, now that oil has to build some pressure and it has to do some work. So there's two more cartridges involved that are going to allow this machine to build pressure. The important cartridge is what we call the Unloader Cartridge, and this is hiding right underneath the accumulator. This cartridge is a pressure sensitive cartridge. It works within a certain pressure range because its goal is to keep the accumulator full at 2300 psi of oil pressure, because when it comes time to shift that swing tube, we need full pressure to do it. So we have this set to 2300 psi on an A30. Once 2300 psi is reached, this unloader cartridge now sends a signal to a relief cartridge right here on the side of the manifold. Okay, and essentially it pilots this relief valve open through a side door, you can say, and it allows that oil flow coming from the gear pump free access back to the hydraulic tank without any restriction whatsoever. So now the accumulator would be full of oil, the circuit sitting at 2300 psi, and as soon as our valve shifts, the cartridge that's holding that oil pressure back is going to let the accumulator literally pushes that oil out. It expels it because it has a bladder within that's full of nitrogen, dry nitrogen. Okay, so now once the oil flows through the directional cartridge, it goes back to shift the cylinder in a flash. Okay, now this unloader cartridge senses a drop in pressure because the swing cylinder shifted, consuming the oil that was stored in the accumulator. Now there has been a drop in pressure. Now this cartridge is going to come back online and it's going to refill the accumulator, and the process is going to continue to repeat itself. The accumulator quickly fills with oil, pressure gauge builds to 2300 psi, and as soon as we reach that value, now the cartridge is saying, I don't need any more oil flow. So once again, it's going to pilot our relief valve on the side of the manifold open so that the pump that's feeding the swing circuit oil can now free flow it back to tank. Our circuit has 2300 psi. That's all it wants to see, and now it's happy. Okay, one more relief valve we're going to cover is on the front side of the manifold. This would be on the operator side of the machine now. And this is our relief valve for our main circuit. Set to 3000 psi. Hopefully about the only time you're ever going to see that type of pressure on your machine is when it's plugged up. That's what the reverse function's for.